Hello everyone. Today I will be explaining the course program we use in our motion sensing based project. So let's start with it. First, you can see this three lines of code. These are Blink template ID, name, and authent token. When we are using Blink IoT to check for Blink IoT to check for the graphs, we are using Blink IoT to check the motion counted by our master and slave PIR. So here you need these three lines to verify your Blink IoT. Then we have header files. This includes Wi-Fi.h, ESP-now.h, Blink simple HTML. Wi-Fi.h needed for the Wi-Fi STA, the station mode. There where you can check your Wi-Fi channel and stuff and connect it with Wi-Fi. ESP now needed for our ESP now two wireless connection between two ESPs, and we need Blink simple ESP to H header file for our Blink to get data or Blink function to run in our program. Then we have define LED PIR pin, where you define which pin you will be using for your LED's PIR and LED to go. This LED 16 is the output. It takes the output to the LED, and the LED will glow according to your logic. And second is PIR pin. This is the D13 pin in your ESP32. The PIR will send output to the ESP32, and it takes the ESP32 will take the output as input, and according to it the logic will work. Same as for LDR, it checks for day and night, and it just checks for motion if there is a motion. Then you need uh, your Wi-Fi password and the name or Wi-Fi details. You can give it here. You need it for your Wi-Fi station mode or Wi-Fi connection. Then you have this line. This is the line. This is the MAC address for our slave. Why do you need this? It stores the image. It helps to know that you're using ESP now. You know that, and you can't just like send to anywhere. You need a specific address, like how you order stuff and you give specific address to your about your house. Same as here, you need to give a specific address which ESP you are sending. Here, and my slave address is this, and our when the motion this in our logic, slave will send data to master. So this address from this address, the information will receive from the issue. The master will receive the data from this address. This is the address of our slave where the data is coming from. Then you have this type structure message. This is the structure from in C. This contains the data. This data is what data? There is an array or string is coming from slave, and it containing here. Where in future in the further code you will see why this is needed. A string is saved here. When the data is come and when the data came from slave, the string saved here. Then we have this the data that come here is stored in my data. Then we need to I'm not further in detail. Okay. Then we have this the declaration that constant PWM channel, PWM frequency, PWM resonance. PWM channel is that ASP32 has 16 channels, 0 to 16, where for motion, which is the pulse width modulation is generated. Pulse width modulation generation is that the average voltage is on and off, or lower and higher, or you can say that the voltage is on and off. As a disabled, it generates pulse and give it to the LED, and we can see dimming for that. And one of the channel is zero. Frequency is how per second how much on and off is happening. Here 200 hertz is happening, and resolution is the duty cycle is 0 to 255. 55 duty cycle, where duty cycle means it resets every time. Okay. Then you have the integer max brightness, where the brightness is the maximum in our case 70%, lower brightness is 10%. Beam shade is 10%. Every 1 second, 10% will decrease. Previous millis, if is the this millis is a like we can last motion here. The it would detect when the update was sent. This is previous before update. Like no update happened in our board. When the millis is the function that millis here you can see is the function. It checks for the how much when the board starts. This starts a countdown. This function starts a countdown. So we put a millisecond for our future when the last or motion or brightness change time. It will get minus and you will see there's a timeout. It will after 10 seconds without motion, the dimming will start. And if no motion is detected, interval dim is every 10 seconds is happening. PIR state is low because when we start the boat, we can't just put high. We need to put it at low that no motion is detected at first. Last year is literature low. Last year state for the age detection. Last year, last night is false. Means that it is future and day night time. Then continuing on, this is check for last what that false check for if it's day and night for the curve compared to current. Earlier now it shows the earlier value and brightness is low brightness. Always current brightness is always be at low brightness. Then we have motion from the motion that has been taken from slave is always false because we don't want it to be high so that the LEDs will glow and motion timeout is 0. Motion timeout is 5 seconds. Okay, so master computer, this is a result for the blink. This is the main important. This is the function where the the data is coming. This function receives the data that is coming from the slave. Here you can see how is it work. If the MSC address incoming data all are checked here. If the data came from my data. This stores the string. This stores the string which I talked before. This is the string that store that the slave send the string and the store in my data. If the my data has this string equal and it is equal to 0, that those two are equal, then if the motion spectrum will be true and the LED will grow. And then the timeout will start to check the similar thing that after 10 seconds the brightness will be come to the initial state. This is for it was false when no motion was detected, and when we come to the LEDs will be at the max brightness, and this checks for the string. Then we have doing virtual, it checks for the motion count, and the graph will be formed. Then we come to the bird setup. Serial begins a bird rate, and which bird rate it will say happening. This is pin mode where the we setting up the pin mode where it takes pin IR pin as input, LR pin as input, and it gives LED output. And to it takes the motion input, day and night input, and this for LED to blow or turn on. These are setting of the PWM channel frequency and resonance, and this is attaching the LED with the channel. Then this will generate the PWM, and this LED will take the PWM pulse width modulation to the gradually decrease, increase, or according to the pulse width modulation it will change its brightness. Wi-Fi unit is connect the Wi-Fi to check the Wi-Fi. Then this is the blink this start Wi-Fi mode STA is for the user who set Wi-Fi to the station. Any Wi-Fi is in the register PIR slave. PIR is a register is PIR. It is a wireless protocol. It is a direct communication. So it knows that we are direct communicating with the slave. This is the slave PIR info, and this is the same channel. If we connect the same master and slave to the same channel, then after that, the master can receive the string or the ESP now is getting right. ESP now is working. This is the function we are calling that is the function we call to receive the data. And this is the LDC right. We just set set the duty cycle of the PWM signal and PBS mil is milli is count. Then we go to white loop. White loop in make times unit equal to milli. This function is as I said, this starts the countdown when the board has started. Board is started. Board is start a countdown. And this is PIR value, which stores PIR pins for input high or low as a future true or false. Same for LDR value. It I'm sorry. It stores that LDR pin stores value as one and zero. One for day, zero for night. No, no, I'm sorry. One for night, zero for day. So it is one for night. One for night means true, and zero for night is false. So moonlight will save as usual to always be in moonlight. Moonlight is always be true. It will be eventually come in handy for our logic when we say. Let's start with this. We check for the condition. Here, PIR value stores the PIR piece value as true or false. Last PIR is bool PIR is equal to low. Since PIR sensor send motion send the his output output as high or low. So it is either low or low, and we use the this data type, so it makes low as false and high as true. So when the most first we started, so this is we know this is false, and if there is no motion, this is false. So last year is BR value, which means future. This is false means last year is again false. But if it is not equal to zero, if it's true, if it's become true, and if it's not, they are not equal, this means not equal. Then last pair become pair value, which means that if it's become true, then this line will execute. Means that the last pair that was low will become now true. Then again, if it's false, then it will not be equal, then it will become again false. Here, pair change is detected. Then we Okay, continuing on. This is the nightfall detection. That a night is this is a variable that stores what LDR has said. But for each now, that LDR value one means night and zero means day. Night once means you say the night and zero means day. So with LDR value, there's the LDR value. It will be take for true or false, and then it will if LDR value is equal to one, then it will night will become true, or otherwise it will not. I mean, it's always the true. When the LDR value is become loop as a loop, this is in loop, so it will become false true, and it becomes true, and this becomes true. And last night we can see that last night is false, and we have found the relay false, and the logical not make it true, and this condition this is for the board to get updated previous release with the current release. So we know that board had updated, and at 20%, and when the nightfall detection is the 20%, it will be 10% bright. When it is night, and the last night become the night. This is for the motion instead of timeout, reset the slave motion. How continuing? This is when the motion comes from the slave. Like this is where it is described it. That this is the when the data received from the master incoming, the motion from slave is true. It comes here and it checks for this is checks for that the current board time, that the minute minus the motion value. If it's greater than the timeout, then it becomes false because the motion came from it. It's actually true. It will remain true because we declared it, but we need to make it false. Makes it we will always make it LED glow. So we need to make it false. So the LEDs will be not. Then we move on. This is the motion from slave master, either master or slave. Either of them detect this using the and the or logic. So if we one is if it's true, this false, it will and the output will always be continue on. We talk about motion from master to slave. If master PR value, the PR that master detected the motion that coming from the slave, either of them is true. Either of them is true, the output will be true because we are using the OR gate here. So if it's zero, if it's true, if it's false, it will always be true, and the night is true, then this will execute that the LED will become max. There is an update happened to the board, so the current millis will be equal to current millis, and the motion from slave is equal to false. Reset after use. After use, it will become reset. And we have to, if there is no motion detected, so there it is. And if we are look that this is for the blink, that blink will store the master count, how many times master motion, master here is detected the motion, it will go to the blink graph. If there is no motion, then there is no PR value. If it's true, it will become false. Then and this is time unit interval is greater than then if this and true and true that there is no motion and the interval is this is greater than interval, then the brightness will eventually go low. After 10 seconds, after 10 seconds. And this is the beginning that if there is no motion at night, the time level, the brightness is less than zero, the brightness will go fall eventually. There is happen update and it is night and there is a update, then it will fall eventually. Beam step, this means how many percent frequent per second is the beam step is 10%. And if brightness is less than brightness, then brightness will be, if brightness is less than low brightness or equal to low brightness, then brightness will be this is equal to this. There's a delay, and if it's daytime, the brightness is not equal to zero, then brightness will be equal to zero. Now, if this is for it was for debug. I have forget to remove it, but this is for debug. Wait, this was for debug. I'm sorry. Wait. This was and this is the LED signal. Apply the brightness. This was our master code, and here we go into the slave code. So this is so everyone, this is our slave code. It's the same header file as the master code. There's a PIR, the slave that slave as PIR. It will the pin and the small LED. It is for a small indicator LED on and off. It is there to verify the ESP now. The same Wi-Fi, and we need MAC address where the slave is sending the data. This is the data that we will send saves there, and the motion that saved there, it will go to, and where the string is saved here, that will go to the master. Last PIR means that the PIR will be the board starting with last PIR false because in our logic we need it. As positive we need the debug, but yeah. LED start is zero, LED active is false, it's not active, it will false. So yeah, this is the Wi-Fi safety mode. We know that this is the Wi-Fi within all the setup here. Here this is the ESP now PIR info. This same as where the Wi-Fi channel is for Wi-Fi connection. This is all the calls and stuff. This is the loop part where the moving that bull PIR, this stores PIR high or low inputs, which makes it true or false. Bull makes it true or false. High means true, false, low means false. If PIR and the last PIR, which is false, it becomes true. If two are there is a motion detected. And the small LED digital, right? The small LED, if the motion detected, the small LED will go high. LED starts, and there is a countdown. LED active becomes true. This is the motion that send that SPC motion. This result will be saved in the structure, and this will go to the master ESP. Last year become PIR. The if the LED active, this time is true, and the millisecond is later. Then the digital LED becomes low, and the LED becomes false, and it comes to zero. So there's nothing to say. This is the same as the master, but it's just have a duty of sending the ESP now. There's a small LED to verify the ESP now. The motion detected by the master. So slave will go to the master.